The Los Alamos Neutron Science Center, formerly known as the Los Alamos Meson Physics Facility, is one of the world's most powerful linear accelerators. It is located in Los Alamos National Laboratory in New Mexico in Technical Area 53. It was the most powerful linear accelerator in the world when it was opened in June 1972. The technology used in the accelerator was developed in part by the nuclear physicist Louis Rosen. The facility is capable of accelerating protons up to 800 MeV. Multiple beamlines allow for a variety of experiments to be run at once, and the facility is used for many types of research in materials testing and neutron science. It is also used for medical radioisotope production. LANSCE provides the scientific community with intense sources of neutrons with the capability of performing experiments supporting civilian and national security research. The Department of Energy, National Nuclear Security Administration, Office of Science, Office of Nuclear Energy, and Office of Science and Technology, the principal sponsors of LANSCE, have synergistic long-term needs for the accelerator and neutron science. That is the heart of LANSCE. LANSCE provides solutions to national security problems. It serves an international user community conducting diverse forefront basic and applied research. History. Since 1972, the 800 million electron-volt accelerator and its attendant facilities at Technical Area 53 at Los Alamos National Laboratory have been a resource to a broad international community of scientific researchers. The Los Alamos Meson Physics Facility, as it was originally called, hosted about 1,000 users per year to perform medium-energy physics experiments. In 1977, a pulsed spallation neutron source was commissioned to supply moderated and unmoderated neutrons to time-of-flight experiments in the facility called the Weapons Neutron Research Center. Neutron scattering experiments were started immediately, and by 1983 the Department of Energy's Office of Basic Energy Sciences was funding a formal user program. Beginning in 1985, with the completion of the proton storage ring that compresses proton pulses from 750 microseconds to a quarter of a microsecond, the Los Alamos Neutron Scattering Center, now known as the Luyan Center, was established while WNR was expanded to other spallation sources on the accelerator beam. In 1995, LAMPF was renamed the Los Alamos Neutron Science Center to reflect the broad base of neutron research being conducted on behalf of the weapons program and basic research. The name of the BES Neutron Scattering Facility was simultaneously changed from LANSCE to the Manuel Luyan Jr. Neutron Scattering Center. In 1996, a Memorandum of Understanding was established between the Department of Energy's Officers of Energy Research and Defense Programs to define the stewardship of the facility and its experimental areas in the context of the new Scientific Stockpile Stewardship Program. In 2001, the MOU was rewritten to include three branches of the Department of Energy: the National Nuclear Security Administration Defense Program, the Office of Science, and the Office of Nuclear Energy, and the laboratory officially designated LANSCE as an approved user facility. Several key events have occurred during the last 20 years that have fostered the growth of the user programs at LANSCE. In 1968 through 1995, the DOE Office of Energy Research funded LAMPF as a user facility for medium energy physics, and a user group was incorporated in 1972. Beginning approximately in 1977, Office of Basic Energy Sciences has provided funding of a new experimental area completed in 1990. Including office space. The Los Alamos Neutron Scattering Center became a designated national user facility. In 2011, this status was extended to WNR and PRAD facilities. Users conduct research at 5 state-of-the-art facilities at LANSCE, Isotope Production Facility, Luoyang Neutron Scattering Center, Proton Radiography Facility, Ultracold Neutrons Weapons Neutron Research Facility, Isotope Production Facility. Los Alamos National Laboratory produces radioactive isotopes for medical, environmental, industrial as well as research applications. The Isotope Production Facility at LANSCE supplies a wide range of radioisotopes to researchers all over the world and has been a leader in developing and producing new and unique isotopes for research and development. Luoyang Neutron Scattering Center. The Luoyang Neutron Scattering Center employs a pulsed spallation neutron source equipped with time-of-flight spectrometers for neutron scattering studies. Neutron scattering is a powerful technique for probing the microscopic structure and dynamics and is used in materials science, engineering, condensed matter physics, chemistry, biology, and geology. Proton Radiography Facility. The Proton Radiography Facility uses 800 MeV protons provided by the LANSCE Accelerator Facility to investigate dynamic experiments in support of national and international weapons science and stockpile stewardship programs. Ultracold Neutrons. Researchers working at LANSCE and 8 other member institutions of an international collaboration are constructing the most intense source of ultracold neutrons in the world, measuring ultracold neutron production in their new source for the first time. The ultracold neutron extraction port at LANSCE delivers neutrons from the new ultracold neutron source for experiments that could answer questions about the fundamental constants of nature and aid in the quest for new particles. Weapons Neutron Research Facility. The Weapons Neutron Research Facility provides neutron and proton beams for basic, applied, and defense-related research. Neutron beams with energies ranging from about 0.1 MeV to more than 600 MeV are produced in Target 4 using the 800 MeV proton beam from the LANSCE, LANAC. In the Target 2 area, samples can be exposed to the direct 800 MeV proton beam. User Program. LANSCE's user program ensures the research it oversees represents the cutting edge of nuclear and materials science and technology. The user program plays a key role in training the next generation of top scientists, attracting the best graduate students, postdoctoral researchers, and early career scientists. The constant influx of users to LANSCE and the interactions with them benefit the laboratory directly. Users help keep the laboratory in touch with members of the external scientific community, who bring new perspectives and fresh ideas with them. In addition, many of the laboratory's scientists have the opportunity to collaborate with the users and thus continue to be engaged in forefront research that hones their skills. A significant number of students and postdoctoral researchers who become familiar with the laboratory through their experiences at LANSCE become part of the permanent workforce, joining many different technical organizations and making important contributions to the laboratory's principal missions. User demographics. The user program's demographics count user visits and unique users. User visits are the total number of visits by all users. A unique user is defined as counting a user only once, the first time they come to LANSCE during a calendar year. The largest segment of unique users at the Luoyang Center came from the academic community. At WNI, users come from academic, industrial, and national laboratories. A majority of the WNR industry users are from firms that produce or use semiconductor devices. The semiconductor industry relies on WNR's unique capabilities to test their latest generation of chips for resistance to neutron-induced upsets. Neutron-induced upsets produced by energetic neutrons are important due to the natural production of high-energy neutrons by cosmic rays.